Hello viewers, welcome to JNTUA. Today our topic is Cayley-Hamilton Theorem statement. What is the statement of Cayley-Hamilton Theorem? Every square matrix satisfies its own characteristic equation. Square matrix means A is any square matrix. It satisfies its own characteristic equation. We know that characteristic equation is, for example, A is a matrix. We have the characteristic equation for 3 by 3 matrix lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. So what is the own characteristic equation means, if in the place of lambda we want to substitute a cube minus s1 a square plus s2a minus s3 for the matrix equality into I is equal to 0. This is the meaning of the Cayley-Hamilton theorem. Every square matrix satisfies its own characteristic equation. This is the characteristic equation. A satisfies this equation means a cube minus s1a square plus s2a minus s3i is equal to 0. Now come to one of the example. Verify Cayley-Hamilton theorem for the matrix A is equal to 7, 2, minus 2, minus 6, minus 1, 2, 6, 2, minus 1. How to verify this? First we want to find the characteristic equation. After that we want to substitute instead of lambda we want to substitute capital A. Then it will satisfy or not we want to check. So that given the matrix A is equal to, so to find the characteristic equation we write lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. Here we want to find s1, s2, s3. How to find s1? S1 is equal to sum of diagonals of A. So sum of diagonals, these are the diagonals 7, minus 1, minus 1. The sum of these three diagonals are, this is 5. Next s2 is equal to sum of minors of diagonals of A. So this is the diagonal element. The minor of this element is by leaving this row and this column. Minus 1 to 2 minus 1 you will get. Next plus next diagonal element this one. By leaving this row and this column 7 minus 2 6 minus 1. The next minor. Next plus the next diagonal element this one. By leaving the same row and the same column you will have 7 2 minus 6 minus 1. So this is the third row last element minor. Here do the minor values. So minus 1 into 1 1 minus 4. So next here minus 7 plus 12. So here minus 7 plus 12. So that here minus 3 plus 5 you will get s2 value as 7. So next come to s3. Det A is equal to, what is the det A? How can we find? This is plus minus plus. Find the determinant 7 into the minors. This is a 1 minus 1 to 2 minus 1 minus 2 minus 2 into minus 6 to 6 minus 1. So next minus 2 into minus 6 minus 1 6 2. So that simplify here you will get 7 into, this is 1 minus 4 minus 2. Next 6 minus 12 minus 2 here minus 12 plus 6. So simplify this you will get 3. Next what is the equation? You will get lambda cube minus s1 5 lambda square plus s2, that is s2 lambda. So what is s2? 7 lambda minus s3. s3 is 3 which is equal to 0. To verify the Cayley-Hamilton theorem, what we want to show? We want to show that a cube minus 5a square plus 7a minus 3i is equal to 0. So that first we need to find a cube and a square. Here a cube, a square are there. So a cube, a square we want to find. By the calculator you can find easily a square and a cube. You can see in the previous video. What is a square? A square is equal to a into a. Here a is there. This is the a into a you can get through the calculator. This is 25 8 minus 8 minus 24 minus 7 8 24 8 minus 7. A cube also in the same procedure you can calculate. A cube also you can find. Substitute here a cube and a square minus 5a square plus 7a minus 3i is equal to, by simplifying this by the calculator also itself you can do. So by simplifying this you can get 0 0 0 0 0 0 0 0 0. Hence verified the Cayley-Hamilton theorem. థ్యాంక్ యూ. ఈ వీడియో మీకు నచ్చినట్లయితే సబ్స్క్రైబ్ చేయండి. ఏదైనా డౌట్స్ ఉంటే కమెంట్ చేయండి.